Hello there. In this video I'm going to talk about software development life cycle and methodologies, and we will first look at the software development life cycle and what different type of methodologies are available. We will just check a few of them which is more related to us, and let's go and move to the next slide. Now, what happens in the first phase of software development life cycle is that this is analysis. So first, when we do the analysis, we have to find out who will be using the system. And once we find out who will be using the system, we need to find out what will the system do, where and when it will be used. And there would be many other questions that would be related to the analysis and that we need to find out in the very beginning. And once the analysis stage is over, we move to the next stage. And as you can see in the is systems, what we are doing in the analysis that we need also to find out in the beginning is that what is the system as it is, means the system already exists, and we have to also find out what the problems are. And once we find out what the problems are, what the system is already exists, then what the solution has to be provided, and what would be the system that would be given to the customer or the client. So there are two types of the system: as a system already that exists, and to be system that would actually exist after the project is complete or after the system is ready. So that's the current system, and we need to identify the improvements if the current system exists, and if it doesn't, then we have to build a completely a new system. Now what happens is in the beginning, actually when you are doing a business analysis, you have to do the requirement gathering. In the requirement gathering, you may have to need to interview the clients, the stakeholders, and many users, and you get the feedback from the sponsor and the other peoples like the user of the systems, and you have to talk to many people depending upon who's going to use the system and whom the system is going to really affect it. Now, once that analysis is over, let's go to the design phase of it. And what happens is that we actually try to build the system. We may build a system. If we cannot build the system, we may buy a system, depending upon what exactly we are trying to do. It is also that it is possible that the system is available with somebody. We need to actually incorporate that system and buy it and put it and give it to the client, or we build a partial system and we buy a partial system from some other vendor and actually give the solution. The other thing is that hardware, software, network infrastructure that will be used. We also need to find out what the hardware would be, what the RAM would be required, what the hard disk and the other things, and how many networks are there, what type of network would be using, what's the different type of software is available, what's the platform, whether it is a Linux platform, whether it is a Unix platform, or Windows platform. It also needs to be found until and unless we do not find out what the platform is, what is the front end, what's the back end, whether it's web designed application. If it is a web design application, so what will be the, whether they would be using Java or whether they would be using ASP.NET, whether the programming would be in a C hash or it would be a VB, and all those things you need to find out what really was going to happen to the system. How the user will move through the system, the interface, and the menu. And now that's the something little bit older. If you want to design a system for a desktop, then you will have to be looking at how the system will move through the interface and the menu and ribbon. However, in the web page, actually you can have only the menu that's already available on the top of the, or you can have a hyperlinks, and but ultimately how you want to design the interface has to be actually put on the paper or on some of the software that are available to design the wireframe diagrams and other things, and you have to create that screen and so that the user can see it, and the sponsor also can see it, that what exactly they want and what exactly you are trying to give, and then you can proceed with the design further. Database and file specification are developed, yes, but naturally everything goes in the database. Without database, it doesn't make any sense for any product to be created. Whatever you are going to put into will go into ultimately in the database. All the things that are put as an input ultimately lands up database, and everything, whatever inputs and whatever the system does in the end actually results into the reports. If that is not understood by the design, then the design fails. What does the customer is going to give you an input, and what will be the in the end the output. The output for the stakeholders would be always in the forms of the report. The stakeholders are rarely interested in what data entry is being done and other things. That is not they want basically this would be our input, and the report should be about this thing and this thing and this thing. That's what exactly the stakeholders would want. They are not very interested in how the system works. It's the user who would be very interested on how the system works, and because the user has to use it. And the management only is interested in what would be the output of the system. So that being said, then we move to the what each program will do. We need to explain it to the person, the stakeholder and the users, what the each program what we are actually doing is actually what is the function of that program, and that is what is exactly the design phase of the software development life cycle. Then we move to the next stage, that is known as implementation. Now what is implementation? System is really built into really actually what is happening is really now the system starts actually coding starts and everything goes into the development, and you can go and look, and there are many versions and you are getting updated every time. Many things happening in part of the cycle. This is the phase which is most expensive and the longest, and here you will have to look for the developers, the project managers, and everybody is actually working on this project is here. The person who's the designer, the person who's the modeler, everybody would be here, because this is the longest phase, and if something goes wrong, it will happen here. You have to remodify, new requirements come, modification requirements come, they will happen here. And this is being the most expensive and the longest, because any modification needed by the person, they will have to request for it, and the modification request is sent, and the request is that's why the modification request is more expensive normally. If the project is not thought out very carefully from the very beginning by the user, the stakeholders. This phase has 3 steps. Let's go to the 3 steps. System construction. Now what is happening is system construction. I mean is coding and doing everything, and ultimately build and test. What is testing? There are different types of testing, of course. You are testing the system, and you are first testing the check for the bugs. Bugs is a problem like system doesn't perform exactly as it should be, or it is giving you some errors, or it is not performing exactly as it's supposed to be, or it's not giving the right output of the reports. All those things comes in the bugs. Then install the system and teach users how to use the system. Help manage the changes caused by the new system. Install the system. Now once you have created a system, you definitely need the user to use it. The user to use it, you need to install the system. Of course, once you have installed the system, that is great, but then again the user has to be trained how to use the system, otherwise it's of no use. The user may basically, if you see, the user has a little bit big problems in actually adopting to the new system, because the users are already used to the old system. So whenever a new system is shown, it actually is like a little bit of a shock to the users most probably, because the user may have to now actually have to learn the new system and have to refer to the manuals and other things. Now let's help manage the changes caused by the new system, and it is the job that we need to actually make the user understand the system, and we also need to train them how to use it and how to make them understand what exactly the system is supposed to be doing and how it is to be doing. Support plan, this is known as post-implementation. Support plan is basically if something is not working or something is not performing exactly as we wanted to do. So that's how actually it is to be. That is how exactly the person will ask for it, and we need to support that application if something goes wrong, and that's it. And then we move to the methodologies. There are many methodologies, as we can see in the software development, the life cycle, as you can see. And let's say we go to the waterfall. If you see that the waterfall methodology, in the waterfall methodology, the analyst and user proceed in a sequence from one phase to another. Now what's happening is that waterfall methodology actually divides the whole process into the different phases, and it will actually completes the one phase and then moves into the second phase. I will just move to the diagram before actually moving it. Actually, there is a planning phase, there is an analysis phase, there is a design phase, the implementation and system phase. What is happening is that the planning has to get completed before analysis can begin. In a waterfall, and once the analysis is finished, the design phase starts. Once the design is finished and implementation starts and the system is ready, you can go back in the waterfall method, but it's very expensive because the planning has taken place completely, analysis has been taken place completely, design takes place completely, and then implementation takes place and the system is delivered. Now if suppose somewhere you want to get modified, then it becomes very expensive because the whole thing has to be taken back in the waterfall method. So if something goes wrong here in the implementation, because this design is completely finished off, this has been completely finished off for the whole project, not for the particular part of the project, but for the whole project. The planning is finished, and then it goes to the analysis, it is completely finished, and then it goes to the design, it is completely finished, and implementation, and then the system. Let's go back a little bit back. So in the waterfall methodology, the analysis and the user proceed in the sequence from one phase to another. That's what the different phase means. The key deliverable of each phase is presented to the sponsor in the project moves from one phase to another. Now what's happening is here that the planning is finished and the sponsor is actually showed what exactly is going to be the part of planning, and then the analysis is finished, and again the sponsor has been shown what the analysis have been come to the, and then once it has been acknowledged by the sponsor, it moves into the design, and then again acknowledged by the sponsor, then it goes into implementation, and then however, if there is a problem like there is a modification request, it becomes very expensive because it has to go again to from the very beginning to the bottom, and second phase and third phase again it has to be modified all. It's very expensive to actually have a modification in this thing. And as you can see, is the process important or the data important? Depending upon the methodology in the waterfall are followed. You can have there are two different types of people, different type of system people. Some people believe that the process is more important than the data, and some people believe data is more important than the process. Depending upon what they feel important, and that type of methodology is followed in the waterfall. Process model diagram for who think process is more important, and data model diagram for those who think data is more important. So depending upon whether you think if the process is more important, then the process model diagram would be actually created. If you think that the data is, or if you think both are equally important, then you can have the process model diagram and the data model diagram both. Now that's how that's exactly planning, analysis, design, implementation, and system. That is waterfall method. It is just the way to show it because it is just like it is called waterfall method for the same reason, because it is just like the water is falling from the very top, and it's very difficult to go back in the same direction of the waterfall. Now let's go to the advantage of the waterfall method. Identify the system requirement before the programming begins. Basically, because it is waterfall method, it completes the phases and it identifies the system requirement before the program begins, minifies the changes requirement from one phase to another. Now design must be completed before the programming starts. Long time between analysis phase and delivery phase. Design must be completed before the program starts. That's because all the phases have to be finished. Disadvantage of the waterfall. Now what happens is that because the design has to be finished The programming cannot start until and unless the design has been finished. So if you see, what happens is that no coding happens till the planning and analysis take place. Only after the analysis and planning take place, then only the design can start. Till that time, there is no coding, and so the developer are just sitting idle, or we do not need a developer here till that time. Let's move to the long time between analysis and delivery phase. It's because it is the phases, the complete planning has to take place, so it will take a long time. Then the analysis will take a long time, and the design and the user is not going to get anything to be used till the complete system is completed completely. There is no partial system given to the user. It is not shown nothing. When only all the system, for the full system is complete, it is given to the user. Only then the user can actually start using the system after getting being trained. If something is missed, very expensive to modify, as I already said. If something is missed, because the waterfall method is very expensive to modify it, user never prepared for the introduction of the new system, because the system is completely from all the phases and given to the user. The user is not aware of what the system is doing, and it is not the users are not prepared for the new system. That really actually gives them a little bit of shock with such a big new system that has come into the action, and they have to actually now have to get adapted to the new system and to learn the new system. Now let's go to the another methodology after waterfall. They are known as parallel development methodology. Before we go, actually let's see what it looks like. This is what a parallel methodology would look like. Let's explain. Let's go to the explanation. It performs a general design for the whole system and divides the project into the series of a different sub-project that can be designed and implemented parallel. Once the project is finished, the several sub-projects are integrated together. What it's doing is that in the very beginning, it actually creates a general design for the whole system. And once the general design for the whole system is created, then it divides the project into a different series of sub-projects that can be designed and implemented. What is this? Breaking up the project, and after dividing the project again has to be goes into the same process like a designing and implementation. Once the project is finished, you bring all the. It's like the jigsaw puzzle. You make something, you make something, you make something, and ultimately we bring it together and we fix it. Just like actually, if you're seeing an aeroplane being made, you see that the engine is being built at one place, the interior has been built at one place, and the electronics may be built at, and you just bring them together and fix it. And that's what exactly this is how it works like. So this is known as parallel development methodology. Advantage of parallel development methodology is to reduce the time to deliver. Less work is needed because the project phase is divided in many of the things. So what happens is that many different groups are working at the different part of the project. So it becomes much faster. It actually and less rework is needed, because actually one system whatever actually creates it, another system can use it, and that's what actually takes less time. Less rework is needed. Reduces time to deliver the system. However, disadvantage of parallel system, because the system is worked completely on the paper, designs, a lot of paperwork is added. Some of the sub-project may not be independent, and so the decision made in one sub-project may affect the other. What it means is that maybe that the projects, though they had been divided, but some of the part of the project may actually depend upon the other project, other sub-project group. So what happens is that it may create a problem, because that the first part may depend upon the second part, and the second part may depend upon the third part, and the third part may depend upon the first part. We cannot say what is going to happen, but depending, it is later realized that this is dependent upon the one part is dependent upon the other, and it can actually create it is like a disadvantage in system. Let's move to the what is happening in the parallel development methodology is that if you see If you see here, this is the this is the planning, this is the analysis. Now what has happened here is that we have three sub projects getting divided. So what's happened is that planning, analysis, design has come here. So design, implementation, you can see design, implementation and design, implementation. This is 1, 2 and 3 sub projects are actually taking place. What's happening is that if you see is that the planning is going to the analysis and the analysis is going to design, and now it gets divided into 3 sub projects. That is once it gets there, again the designing for the 3 sub projects starts designing, and it goes to the implementation and designing. Again it goes to the implementation and design implementation. And what happens is that whatever you want to change, you can go back to the, because there's small sub projects, so you can go back very fast to the design and make the modification and come back. So this is built very fast, and because it's divided in the 3, because the project is already divided, the works move faster. And once it is actually divided, you actually come back here, and then the thing is that integration. In the integration you bring the project together, and once the project is brought together and you integrated the whole project and you actually deliver as a system, and that's how it works. Now let's look at the rapid application methodology, R.A.D. Develop some part faster and give it to the user, and will give the feedback which brings the system closer to the user. R.A.D., that is rapid application development methodology, rapid application development, suggests to use case tools, and JAD, that joint application design session, 4th generation programming like Visual Basic, Visual C++, and code generator that can automatically produce the code from the design. Because of these tools, the user tend to understand the system well, and so the expectation of the user changes. Now what happens is that because the user can understand what the person is trying to do, what the programmer or what the designer is trying to actually show. So what happens is that it is using the 4th generation, and what's happening is basically is using the designing tools that can actually generate code. The user understands the thing much better, and now once the user understands the thing much better, the user expectation also actually grows with it, because the user now understands the things much better and the user expectation grows, and that's the only problem with it. Let's move to the next phase, phase development methodology. Now what is phase development methodology? Breakdown of the overall systems into the series of the versions that are developed sequentially. Now this is the phase down development methodology. If you see, what's happening is that this is the R.A.D. method, rapid application development. Okay, break down the overall system into the series of the version that are developed sequentially. What's happening is that they are breaking down all over the system version and that are developed sequentially. Analysis phases. An analysis phase identifies the overall project system concept, the project team, users, and the system sponsor. Then categorize it as the series of the version. Most important requirements are handled in the first sequence. The analysis phase is then lead into the design and implementation, but only that was identified as the most important sequence and the version 1. Once the version 1 is over, the work begins with the version 2, improving the new ideas, and this goes on till the project is completed. Now this is the phase development, and let's again look at it. What it says: break down the overall system into the series of the version that is developed sequentially. Okay, so this is basically actually it's looking at. Let's look at here. This is planning, analysis, design, implementation, analysis, design, implementation, analysis, design, implementation. Now they have actually broken down the project, and as you can see, there is a version 1 that comes up, again there is a version 2 that comes up, and there is a version 3 comes up, and it goes on till the system is complete. As you can see, analysis phase identifies the overall project system concept. So this is what will happen here is that in the analysis part, everything is actually done, and before actually breaking down the project, and it is here, it is everything is completed. And let's move to the project team, user, system, sponsor, then categorize it as a series of the version. And the project team, user, and system sponsor then categorize in the series of the version. Now I already spoken to you about the version, that actually there would be a version wise implementation in the analysis, design, and implementation phase. Actually, if you see, there is a version 1, and once the version 1 is completed, it comes back again to the analysis, design, implementation. Again the version 2 is completed, and it goes to the version 3, analysis, design, and system 3. And let's move back to the process. The project, the most important requirements are handled in the first sequence version. Now what's happening is that the most important requirements would be actually handled in analysis, that's version 1, and before moving it to the version 2, this is the version 1 that's finished. And let's move to the most important, the analysis phase, that then leads in the design and implementation, but only that was identified as the most important sequence and version 1. Once the version 1 is over, the work begins with the version 2, improving with the new ideas. This goes till the project is complete and no longer used. Once the version 1 is over, the work begins with the version 2. Now improving the new ideas as this goes. And what's happening is that if you are seeing that the version 1 is, it goes to the version 2 and so on. So let's move to the phase development methodology advantages. Now what are the advantages? Quick start using the system before the system performs all the function. So what is happening is the quick start using the system. You start using the system before the system performs all the function. The value to the business is that first you can start using the system much before everything has been done. So it is actually, and the system actually develops much better, because you know what you want and where the system is going. The value to the business is provider. The value to the business is provided earlier than the system will be delivered, as in the prior two methodology, the waterfall and the parallel method. What's happening is that because it is actually getting created much in the part by part system, so the value to the business is much earlier. Means the organization can start using the system much earlier. So actually it provides a value to the business much earlier, rather than to wait till the completion of the whole project and then the system is delivered. So this is much more actually maybe required in the place where the requirement is very urgent and the system has to be used as it is getting developed. The major disadvantage is that the user starts working of the system with the system even before the system. The major disadvantage is the user starts working with it. Now the user has started working with the system before the system is complete, so this can become a disadvantage rather than an advantage. As you can see, planning, analysis, it goes to the analysis, and you can see this is version 1 taking place, analysis, design, implementation. This takes place, this is the version 1, system version 1, and then we go to the again to the analysis, design, implementation. This is version 2 and then 3. What's happening is that the project has been broken down and it is actually getting implemented by versions. Now this methodology uses the minimum R.N.A. rapid application development. This methodology uses minimum planning in the favor of the rapid development. Now what's happening is that this method uses the minimum planning in the favor of the rapid development. What it means is that there is a very low planning, very less, no, not low, very less planning, and they start moving directly into the project and start working on it. It follows iterative and incremental model. What means is that best used by small teams. This is the actually what's happening is that it is actually using iterative and incremental model, which means that every time one they pick up a small project and they go into all the phases of that project and they implement it, and then again they go into the different part of the project, and then they again implement it, and again they go into the third part of the project and again implement it, and that's how the cycle is finished. And it will keep on happening for every part of the project. Now if you see what's happening in the business modeling, data modeling, process modeling, application generation, testing and turnover, prototype 1, business modeling, data modeling, prototype 2, prototype 3, same thing. And this is the automation tail, and that which will generate the application code. Use when high availability of the design. When to use the rapid application development methodology? When use when high availability of the designers for the modeling, because it already depends upon the designer. If you do not have a high availability of designers and modelers, do not use this system. Whenever if you want to design the system with rapid application development, you should have high availability of designers and modelers. Use it when the systems can be delivered in the incremental manner. If the stakeholder is accepts that it can be actually delivered with the part by part system, then and this is the perfect solution. But however, if the stakeholder wants the complete solution from the very beginning to the end, then this would not be the correct solution. Okay, use it when the domain expert of course, because you are developing the system too fast, so you need the domain expert to be there available, otherwise it doesn't make sense. Should be used when the requirements changes in the course of the project. It is definitely better to use the rapid application development if you know that there would be a lot of changes when you would be developing the project. But definitely you use this methodology in that circumstances. Now, rapid application development pros and cons. Okay, let's take it as the few pros and few cons. Deliver faster, as it allows you to reuse of a component and parallel development. Okay, great. That is the first pro. Rapid application development works only when you have highly skilled people working. Definitely, if you do not have highly skilled people working, it will fail, because it moves in the iterative and it needs the highly required modelers and designers to work. If they are not available, then this system is not actually good for use. It is highly dependable on the modeling skills. Yes, definitely it is, because that is a con, because if you do not have the modeling skills, then this system may not be the right system for you. Required highly skilled developers and programmers, because it keeps on working in iterative method, so it requires a highly skilled developers and programmers. Again, is a disadvantage. Not always you may have the skilled developer programmers available with the organization, because of course it takes time and time to train, time to find out a new developer and programmer, time to find out the correct skill. Definitely it becomes a disadvantage rather than an advantage. Management complexity is more, because it is in a iterative mode, so every part of the being actually delivered, the management complexity becomes more. Progress can be measured. That's the pro, because once you can actually, because the project is actually broken in small parts, so every part is delivered, so you can measure the progress, and the user starts using the system, reducing the development, and actually start giving you monetary benefit out of it when you are actually developing the system. Reducing the development time, of course, because it goes into it actually in a different, actually broken the project into different parts, so each part of the project can actually be using the different part that are similar code, or the code that is similar to each of them. So it reduces development time, encourages customer feedback. Definitely it encourages customer feedback, because the customer can see what the project part is doing. So once only the part is completed, it can move into the next phase, next part, and productivity can be achieved with the fewer people, because it is rapidly, you can have small teams that is divided, and the small teams keep on working, and definitely the productivity can be achieved. That's the advantage of the rapid application. Prototype methodology. Okay, again this is performs analysis, design, implementation phase concurrently. All the three phases are repeated until the system is complete. Okay, so analysis, design and implementation concurrently. At the same time, all these phases are repeated till the system is complete. Basic analysis is performed and work begins soon. Quick and dirty program is used to create a system prototype. It is then shown to the user and the stakeholder sponsor, and then the changes are made and the process continues till there are enough requirements met and the requirements and the system is fine-tuned. Now this is a prototype methodology, that is actually where the designing phase and implementation phase is concurrently. Let's go look at the diagram for better understanding. As you can see, prototyping, planning, as you can see, analysis, design, implementation. System prototype is created. Again, it goes into the same phase: analysis, design, implementation. Again, system prototype. And if the thing is that once it is done, it goes into implementation. It keeps on going in this methodology. That is how it is. Let's look at it. Basic analysis performed and the work begins as it shows. The diagram shows. You can see the planning is taking place, and then starts the work, and everything goes on in the same process in the loop. And the program is dirty program. What is quick and dirty program is that they create a fast prototype, fast program, and then use it, show it to the user accepts it, ask for the changes, the changes made, it is shown to the stakeholders want to acknowledge it, and again whatever the actually changes need to be done, it is done through again. It goes again into the same process. Once it is done, actually again the users, again it goes to the stakeholder, again the acknowledgement, again whatever requirements are met, and then the system, once everything is done, the system is everything is continues until there are enough requirements met and they are the user and the stakeholder is satisfied. Then the system is fine tuned. Quick provide the user the system to interact. This is the advantage because the user actually can start using the system very fast. So it is actually provides reassure the user the team is working on the prototype, because they actually start creating a very fast prototype with the quick and dirty programming. So the user can actually see it and actually ask for the improvement, and actually helps the user to actually understand what the system really is doing, and what they want expect the system to do, and whether the system is capable of doing, and actually if not, then they keep on asking the programmers and the developers to actually make the changes, and that's it. And ultimately they get what they want, and it is actually signed off by the stakeholder, and that's fine tuned, and that's it. And user interact with the prototype, and then can tell the designer what it lacks, and so they get the real system that's working to the system that actually I already explained to you what is happening. Now, disadvantage of the prototyping method: because it is fast-paced development, careful analysis should be done. Now, because it is very fast, it is very using quick and dirty programming, the analysis has to be done very carefully from the very beginning. If the analysis goes wrong, then everything goes wrong, because it goes through the rapid changes so fast that many times the initial design becomes poor. Now, this is very important, because it is going very fast through the many process, the same process, many changes very fast. So it actually the initial design can become, it's obvious, isn't it? Can cause many difficulties in the development of the complex system, because the fundamental issues were not raised in the system development phase. As you can see, if something is left out, it will create problems in any project. So this is also one of the thing that can create a big problem in the complex system. And this is the diagram. As you can see, prototyping, analysis, design, implementation, system prototype, again goes back, analysis, design, implementation, again it comes back, design, implementation, design and implementation till they get it correct. And once they get it correct, it is implemented, and then it goes to the system. This will keep on happening. Throwaway prototyping, similar to the prototyping methodology. However, throwaway prototyping are done in a different time in software development life cycle. Very similar to the prototyping methodology, but however little there is difference in the time when it's used in an SDLC. So through the analysis phase to the development ideas for the system concept, each of the issue examined, analyzed, designing and building the designing prototype. Once issued, once the issue is resolved, the product moves in the implementation phase, and all the design prototypes are thrown away. Now, what's happening is that they are creating a prototype. Once the issue is resolved and the product moves in the implementation, they have to throw away the prototype, because prototypes are no more useful. Prototypes are not a real application. They are just a design, and then they have to be thrown away. For example, if the order entry system would work, so simple HTML web pages were designed, mock-up screens are created, but they do nothing. You have to throw away them in the end. It takes longer than prototyping methodology produce more reliable system. Now this is a throwaway prototyping methodology. As you can see, planning takes place, analysis takes place, analysis, design, implementation. And again, if you see, this is a designing prototype. Again, it's going here. Again, it's design, implementation, and systems. Let's move to the next one. Now, this is one of the most famous one that's known as agile development methodology, and the most important is the extreme programming. This is one of the most famous methodology that is being used nowadays. The programming centric methodology have few rules to follow. That's excellent, isn't it? So focus on the streamlining the SDLC, software development life cycle, and trying to eliminate much of the modeling and document. This methodology actually tries to avoid, eliminates the modeling and documentation in the much of it, not everything, but much of it. Project emphasize on a simple iterative application development. What it actually is doing is that it will divide the project in small parts again, I think, and it will go into iterative mode and try to keep on working on the one part till the one part and the second part and the third part and so on. Example of iterative development are Agile, Scrum, and Dynamic System Development Methodology (DM). XP is used in conjunction with the object-oriented methodology. XP is extreme programming. Is used in conjunction with the object-oriented methodologies. XP has the 4 core values: communication, simplicity, feedback, and courage. That is the 4 core values of the extreme programming: communication, simplicity, feedback, and courage. First, the developer must provide the continuous feedback to the user. Keep it simple and sweet. That is the crisp principle. Developer must increment changes. They must not allow accept changes but embrace the changes. What it says is that developer must increment changes. They must not only accept the changes but also embrace the changes. Developer must have a quality first mentality. 3 key principles of the XPs are continuous testing, simple coding done by pair of the developers, and close interaction with the end user to build the system very fast. After the planning process, the analysis, design, implementation phase are done iteratively, and that's how it is done. After the planning phase process, the analysis, design, and implementation phase are done iteratively. Okay, this is extreme programming, and let's look at the extreme programming is continued. As you can see, XP extreme programming projects begins with the user stories, what the system needs to do. Developer codes small simple modules and test to meet the need. They will just make a small modules and just test it and to meet it, whether it actually meets the need. User should clear up the issues as they arise. So what's happening is that when in extreme programming, the user will have to be very interacting with the system whenever it is being created, and will have to clear up the issues if they are as they arise. Otherwise, once they have done, it is done. Extreme programming delivers results faster than R.N.A, as they never do information gathering. Of course, whenever you do not actually waste much of the time on the information gathering, which is a very long process, you will be able to develop the system much faster. So it is actually develops the system much faster than rapid application development. For small project, extreme programming should work fine. These systems use laws of on-site user input, which the business may not commit. Many business may not like the too much interaction of the user with the system in the very beginning. The user may have some other works to do in the organization, so it may not be suitable for that big large organization as such. As you can see, extreme programming, planning, analysis, design, phase, implementation, system. Again, it goes back to analysis, design, system. Again, and it keeps on. And that's it. Thank you very much for watching. Bye bye.